Calculation 7 in Chapter 1, Estimation of Liquid Density. Estimate the liquid density of saturated liquid ammonia at 37 degrees Celsius or 310 Kelvin using the Gunn-Yamada generalized correlation and the Racket equation. The Gunn-Yamada correlation is given by this equation, where V is the liquid molar specific volume in centimeter cube per gram mole. If we can calculate V from this equation, then the liquid density would be rho equal to 1 over V in gram mole per centimeter cube. And if we want it in mass density, we can multiply 1 over V gram mole per centimeter cube by molecular weight of ammonia, which is 17 gram per gram mole, and we can get liquid density as 17 divided by V gram per centimeter cube. Now let's learn about the parameters in Gunn-Yamada correlation. Omega is the eccentric factor, which in this problem is given as 0.25 for liquid ammonia. The other parameters in this equation will be VSC, VR0, and gamma, which we can calculate. VSC is given by this correlation. If we assume a critical temperature of 405.6 Kelvin and a critical pressure of 111.3 atmosphere for ammonia, and using the eccentric factor that we saw earlier, and also the gas constant R of 82.05 atmosphere centimeter cube per gram mole per K, then we can calculate VSC as 82.05 atmosphere centimeter cube per gram mole per K multiplied by 405.6 Kelvin divided by 111.3 atmosphere multiply by 0.2920 minus 0.0967 times 0.25. This will give us a value of VSC as 80.08 centimeter cube per gram mole. Gamma in the equation is given by this correlation in the range of T over Tc that you see. Since the temperature is 310 Kelvin, we can calculate T over Tc as 310 Kelvin divided by the critical temperature, which we saw earlier as 405.6 Kelvin. This will give us a T over Tc of 0.764. If we plug in this value in the above equation, we will get a value for gamma as 0.1987. Note that the T over Tc value falls well within the range of the applicability of the equation. VR0 is given by this equation in the range of T over Tc that you see here, and our T over Tc is 0.764, so therefore this equation is applicable. if we plug in the value of T over Tc in this equation, we will get VR0 equal to 0.4399. Now, let's use the values that we have already calculated for these parameters in the equation to calculate V. V divided by VSC of 80.08 equals to 0.4399 times 1 minus 0.25 times 0.1987. We will get a value for V as 33.48 centimeter cube per gram mole. Having the value of volume, we can calculate liquid density as 17 over V, which is equal to 17 divided by 33.48, and this will be equal to 0.508 gram centimeter cube. This density is equivalent to 31.69 pound per foot cube. Note that the experimental value for density is 0.5834, so we can calculate the relative error as 0.5834 minus the value that we just calculated as 0.508 divided by the experimental value. And if we calculate the absolute value of this quantity and get the percentage, we will come up with a percent of 12.9 difference in the calculated and experimental value. The Racket equation is given by this equation where Vsat is the molar specific volume for saturated liquid, Vc is the critical molar volume, and Zc is the critical compressibility factor. If we assume a Zc of 0.242, a Vc of 72.5 centimeter cube per gram mole, and also we calculated the ratio T over Tc earlier as 0.764, we can calculate Vsat as 72.5 centimeter cube per gram mole multiplied by 0.242 to the power 1 minus 0.764 to the power 0.2857. The value in the bracket is 0.39, and with that we can then calculate Vsat as 28.34 centimeter cube per gram mole. Using this value of V, we can calculate density. Rho is equal to 17 divided by 28.34, and this will give us the density in mass units of 0.5999 gram per centimeter cube. This is equivalent to 37.45 pound per foot cube. If we calculate the relative error, it would be equal to 5834, the experimental value, minus 0.5999 that we just calculated over the experimental value. If we take the absolute value and get the percentage, we will come up with a relative error of 2.8%.